Learn how to add a widget extension to an existing app, including reusing service classes, building UIs for different size classes, and scheduling widget updates through a timeline. Hey Code Crew, this is Flo. I've been developing iOS apps since 2016 and I've been working on many different widgets over the past few months, so I'm super excited to teach you about WidgetKit in this series. This is lesson 1, where I will show you examples for great widgets by Apple, the current project setup, and the example app that I have prepared for you. Next, we will add a widget extension and go through everything that Xcode automatically generates for us. Let's get started with some examples of great widgets, so you understand how all of this works, how the ecosystem works, and how they are built up. So there's this great article from the Apple developer website, which is linked in the description, which just gives a brief introduction to WidgetKit. And I just want to show you a few of the examples that they have on their website here. They have the little calendar widget, they have a weather widget, news, music, also for the activity app, and so on. Then there are a bit larger widgets for the iPad with photos and a bigger calendar view. But one thing that unites all of them is that they have at-a-glance information. So you, for example, in the calendar widget, you only have the next 2 events showing. So when you have a glance at the widget, you immediately know what it wants to show you and what information is there. Same for the weather widget, you just have a quick look at it and then you instantly know the temperature and the current weather conditions. There are also some more widgets that I want to show you that I have personally worked on. The first one is a food tracker app, which is based around a medium-sized widget that you can see in the screenshot in the middle here. And the idea is basically that you can track your meals through a widget where you can just tap either on the healthy or on the junk side of the widget. The app will open up and all of your meals will get logged that way. So there's a tiny bit of interactivity here, but I will tell you more about that in just a second. And then there's also another widget that I made for a SwiftUI Jam a few weeks ago, which is an almost fully working calculator widget. So we can watch the video here. It looks just like the calculator app from your iPhone, but then you can tap on the numbers and on the operators. The app will briefly open up, close back down again, and then you will see your calculation and the end result inside of the widget. I think this is very cool. Obviously, this is not what Apple intended widgets to be, but there you can just see what's possible with the technology. So getting back to WidgetKit itself, widgets are built entirely in SwiftUI. So it is not possible to port UI kit, for example, via UI view representables or UI view controller representables. Currently, you can only use SwiftUI to build out the UI side, so what's displayed inside of the widget. As I said, the main idea is to provide at-a-glance information. These are just tiny portions of the screen. The widgets are based on a timeline. So you, the developer, can provide a timeline scheduled with timeline entries that all have an associated date and some data associated as well. So you can, for example, schedule a timeline over the next 5 hours, where at every full hour there is a timeline entry. And then iOS or iPadOS or even macOS, whichever system your widget is running on, will execute that timeline and refresh the widget by itself. So you're not guaranteed to have the widget refresh at exactly the time in your timeline entries that you have specified, but the system handles it, and the system also has some limitations. For example, you cannot refresh your widget a few hundred times per day. There are just certain restrictions there set by iOS, but most users will never notice this, and for most users the widgets will always stay up to date. We will have a look at the timeline entries and so on partially in this, but mainly in the next lesson. And then one last very important thing when talking about widgets is that you understand that they are static UI. So there are no animations, there are no videos, there is no navigation, and there are also no buttons. The only dynamic thing that a widget can do is link into your main app and pass in some data there. We will have a look at that in the 3rd lesson of this series, but until then you can just assume that a widget is more or less a very static view. Okay, to get us started a bit quicker, I have already prepared a very simple example app. This is a simple to-do list app based on the JSON placeholder API. You might have already seen the JSON placeholder API. If you want to have a more specific look at it, it will be linked down in the description. It's a very generic API with some, as the name suggests, placeholder JSON data for users, for posts and so on, but we are just using the to-dos route, which you will also see in just a second. So the main app only has a single view, which you can see here on the right hand side. If I press play, then all of the to-dos will be loaded. We will have a list here with the to-do title on the left hand side, and then the status, whether it's completed or not, on the right hand side. So some of these to-dos are open, some of them are already completed. And if we tap on a to-do item here, a little sheet will come up telling us the ID of the to-do, then once again the title, and whether it's open or completed. And then you can, of course, dismiss the sheet like always. Okay, so let's briefly go over the content view here so you understand how this all was built, and then we will have a look at our data class, our to-do, and then also our service class. So first of all, as you can already see, we have a navigation title here, so we must also have a navigation view which surrounds everything in our content view here. And then mainly we just have this single list here. The rest of the code is just view modifiers, but we mainly have this single list here iterating over all of the to-dos, which is a state variable here. In the beginning, this is an empty array of to-do, but later on I will show you how this gets filled. And then inside of the list, we just have a simple button for every row. The button action is to set the selected to-do, which is another state variable, to the to-do of this current row. So for example, if I tap on the first one, then that will be the selected to-do, which is used for our sheet here at the bottom. This has the item initializer where you can pass in an optional identifiable item. In our case, our selected to-do state. And if that is not nil, so if there is some to-do selected, then the sheet will show up and show just a simple group box here. I think this is not too important. This is just for demonstration purposes. If we dismiss the sheet again, we have our list again. And then inside of the list button, there's just a simple attributed string, which is brand new in iOS 15, where you can use some parts of Markdown to, for example, bold a region of text. So here you can see these double asterisks before and after the completed or open text, which we just bolded. As I said, this is attributed string stuff, not important for this series. I just wanted to include it to make it look a tiny bit nicer since this is a very plain UI. Okay, let's continue down. So we already have covered the navigation title. It's just my to-dos. And now the interesting part comes. So for our to-do service, I have chosen to use the new Swift concurrency features. If you want to learn more about that, there's also a series about Swift concurrency made by Stuart Lynch. So it will probably also be linked down below. You can go there after this video, or if you have any understanding issues, then you can just go there and have a look at it. But I think it will be pretty straightforward. Basically what we're doing is we're attaching a task to the list. Task is very similar to onAppear. So the code in here gets executed the first time that the view appears, but you can execute asynchronous code in here. So we will have a look at how that works in just a second, but bear in mind, so this task will get executed one time at the beginning, and everything in here is happening asynchronously in a background thread, or can happen in the background thread. It can also happen in the main thread depending on how it is scheduled internally. And all that this task does in this case is call our to-do service.getAllToDos function, which calls the JSON placeholder API, gets back all of the to-do data, and then puts it into our to-dos state variable up here, which will then be used inside of the list. Okay, and then the last modifier here, I already told you about the sheet, so I think this should be pretty clear. Now let's move on into the data folder on the left hand side here. So first of all, we have our struct to-do. It's important that this conforms to two protocols. The first one is decodable, so we can decode it from JSON, which you will see in a second in the to-do service. And the second protocol is identifiable, so we can iterate over it in our SwiftUI list. This just has 4 very simple attributes: the user ID, the ID of the to-do, the title of the to-do, and whether the to-do is completed or not. Let's jump real quick into the JSON placeholder API, and let's go to the endpoint that we're using, which is /todos. And here you can see where this data is coming from. So this is just a JSON file sitting on the server, and there you have all of the same fields that I just showed you in our to-do struct. So you have the user ID, which is an integer, the ID, which is an integer, the title, which is a string, and then completed, which is a boolean. Okay, and then the last file that I have prepared is the to-do service here. This is just a very simple helper class to fetch all of the to-dos from the JSON placeholder API. Since there is no need to instantiate a new to-do service every time that we use it, I just added a static shared instance here, so we can always just say to-do service.shared instead of instantiating a new to-do service. We have our base URL, which is just the address of jsonplaceholder.typicode.com. And then it gets a bit more interesting with these 3 functions here. The first one is a very generic networking function that you can use in any of your projects really. But the important thing is that it is built using the Swift concurrency features. So let's have a brief look at how that works. So inside of the function, we first construct our URL. So when we call this function, we pass in an endpoint, for example, to-dos, and then the function will generate a URL for us. So in this case, it would be https://jsonplaceholder.typicode.com/ and then here it would be, for example, to-dos. So this will be the endpoint. We constructed here, this can fail, so if in case it fails, we will just throw a URL error of bad URL. Once we have our URL, we can use the URL session.shared.data function, which is similar to data task or data task publisher if you were using Combine previously. This function just creates takes the shared URL session, goes to the URL that you handed over, and then fetches all of the data from that URL. This is an asynchronous task, so you have to await for the results to be coming in, and this can actually also fail or throw an error, and hence we need to try to await the data from this URL. This function actually gives back both data and a URL response. So in your app, you might want to check the URL response for the status code or any info that the server gave back to you. In our case, we don't care about that, so we can just omit the second value of the tuple here, the URL response, by using the underscore, and we will just unpack the tuple into our data variable. And then the last step is pretty straightforward. We just construct a JSON decoder, and then we decode our to-do, in our case, from the data. Now the interesting part here is, and hence the name generic helper function, we have some generics here. So we have a generic type T, which basically means that we could use this fetch function to fetch any type of data. We could also fetch some users or whatever, as long as that struct is decodable, as the generic condition here says. So let's see how that works. I have 2 endpoint functions basically. The first one is to get all to-dos from the JSON placeholder, which once again is asynchronous and can throw errors, but this one will return an array of type to-do. And this will basically just call our fetch function up here from the to-dos endpoint. So basically just the one that I showed you in the browser a minute ago. As you've already seen, the fetch function is asynchronous, it can throw, so we need to try to await the result of the function. Since we are using generics here, we need to explicitly specify the type that we want to get back. So in this case, if we want to get all to-dos, we want an array of type to-do, and then we just return the result of the fetch function. And then very similar for the last function, which is called getToDo_with_ID. We can use this one to get the data for a specific to-do, which we're using for the sheet, for example. this function returns a single to-do instead of an array of to-dos. And it's basically the exact same from before. So we need to specify the type over here since we are dealing with generics. And then the only thing that we're changing is the endpoint. So now we're not querying for all to-dos, we're querying for to-dos / our ID. And if we look at that in the browser, so here we have /todos, and now we say /1, for example, this will give us just the first to-do item. Okay, so now that you have seen the sample app that I have already created for you, let's do the last thing for this video, which is adding the widget extension. To do that, it's also very, very simple since Xcode does almost everything for you. You just go to File, New, Target, and then in here you can either scroll through all of the extensions or you can just filter for widget extension, double click it, then give it a name. So in our case, I will call it WidgetKit course widget. Make sure to uncheck include configuration intent. That is something that we're not doing in this series. Configuration intent can basically be used for Siri. It can be used for the user to customize your widget, but this is not important for this series. Once you're done, just hit the finish button. And here you can say activate the scheme if you want to, which what this does is basically it changes the theme up here in Xcode. So once you have an extension, you can select when you're running your app which scheme you want to run. So you can then either run your main app in the simulator or just run the widget extension in your simulator. For now, let's just say activate. If you want to change this later on, you can just go up here and select either your main app or your widget extension. Okay, and then on the left hand side here, you can see that a new folder was generated, which is called just what we entered into the text field. If we open that up, there's just 3 files, a basic info.plist file, an asset catalog that you can use to provide assets like images, and then there's the WidgetKit course_widget file. This file contains all of the auto-generated code from Xcode. Let me go over the extension and tell you a few words about each of the different types that got generated. And actually, let's start at the bottom here. So first of all, same as in SwiftUI, which I just closed, there is also a preview available for your widgets. I'm closing this right now so we have a bit more space. By the way, to open and close that canvas, you can press Command, Option, Enter. And then there is something that you're probably already familiar with if you've worked in SwiftUI before, because there's now this @main widget struct. This is actually super similar to the @main app struct in your normal app, where you have a body in which you just present your content view inside of a window group in this case. But it also has the @main attribute, which basically tells the device this is the entry point to the app, start here, and then it's the exact same thing for your widget. This @main attribute will just tell the device this is the main starting point for the widget, call this, and then you're good to go. So of course this is not an app, this is a widget, and it also has a body. The body has the generic type of, or the opaque type of widget configuration. You can have, there are basically 2 different types of widget configurations. The first one is a static configuration, which we are using, and most widgets actually use a static configuration. And there is also an intent configuration, which you can use if you want to let the user edit the widget directly on the home screen. Not important for this series, but just so you know, there's 2 different types of configurations. And then into the configuration, you just pass basically an identifier of the widget, which is defined up here. By default, this is just the name of your widget extension target. You can change this, of course, especially if you add multiple widgets to your app later on. And then into the configuration, you also pass in a timeline provider. We will have a look at that in just a second. Inside of the configuration, you then have your actual view. Now this has a very long and complicated name. We will change that also in a minute. And into that view, you pass in your timeline entries. If you recall, in the beginning of this lesson, I talked to you about you can schedule a timeline with different timeline entries for set dates, which in turn contain some data that you can pass to your view. And basically these timeline entries here come from your timeline provider and get passed into your view over here. You will see this more concretely in just a second. You can also customize your widget configuration by, for example, giving it a display name, which will then show up in the app library. And you can also give it a description. Okay, let's scroll up a bit here. The next struct that got auto-generated is the actual view. This view gets passed in a timeline entry, which is that piece of data that's scheduled through your timeline. And then this example widget here that gets auto-generated just shows some text of the current date of the entry. So nothing very special here. And then the entry actually doesn't contain any data right now. We will customize this in the next lesson. The only important thing here is that your entry conforms to the timeline entry protocol, which requires the entry to have a date property. And then up here, the most important and most interesting part of widgets is the timeline provider. So all of this over here. The timeline provider is responsible for scheduling your timeline entries for your widget over time for the next couple of hours, for the next day or even weeks, however long you want to schedule it. There are three main functions that you need to implement here. First of all, the placeholder function. This is used when the user is selecting your widget in the widget gallery on their actual device. Then there's the getSnapshot function, which just gets back the current version of the widget with just a simple timeline entry or just a single timeline entry. And then there's the getTimeline function, which you can use to schedule a timeline for your widget, including when it will refresh, how often it will refresh, and which data it will show. The very last thing for this video will be taking all of these different structs and moving them into their own files to make it a bit easier to read and to understand what we're working with. So over here in our widget folder, we will add a new file and call this one provider. And now a very, very crucial detail when you create this file is that it needs to be in the widget target and not in the app target. Now you can hit create. And in here, let's import WidgetKit. And then let's move our provider, our timeline provider, from the generated file into this new file. And let's do the same for the simple entry and the view as well. So create new file, Swift file. Let's call it simple entry. Make sure that the widget extension is checked here. Hit create, import WidgetKit, and then copy over our simple entry, just like this. And then one last time for our view here. So let's hit Command N, new file. Let's call this widget view. Hit create. Here we need to import both WidgetKit and SwiftUI. Let's copy over this struct over here and move it into this new file. And then we can also command click on it and say rename, and then rename this long name to just widget view. Let's also remove this space here. Let's copy the name and make sure that it was renamed everywhere. So for example, for some reason Xcode didn't rename it over here. So let's get rid of these old names and replace them with the new shorter name. In this lesson, you learned about what can be done with widgets and how they are internally structured. You saw that a widget is based on a timeline and timeline entries, which get displayed in a plain old SwiftUI view. Learn about different size classes, building a widget UI, and deep linking into your app in this lesson. Hey Code Crew, this is Flo. In the first lesson of this WidgetKit course, you learned about how WidgetKit works under the hood, how widgets are refreshed, and everything that Xcode automatically generates for you. In lesson 2, we will have a look at building UIs for different size classes, and deep linking into the main app from the widget. Let's get right into it. So we're starting in this lesson right where we left off in the last lesson. And actually we don't need the content view. What we need is our widget definition here. So I already told you in the first lesson that there are different size classes that your widgets can have. So that's the first thing that we will have a look at in this lesson. To have a look at the size classes, configure them, and tell the system which size classes your widget supports, you can just go to your static or your intent configuration, basically just your widget configuration, and then there is a very simple modifier called supported families. Here you can just pass in an array of all of the widget families that you want to support. One note though is that the system extra large family is only available for iPad apps, since it cannot even fit on an iPhone. For this lesson, we will focus on system medium, which is basically 2 rows of apps at full width, and also system large, which is 4 rows of apps, so almost the entire screen taken up by that widget. While we're at it, let's also change the configuration name to my to-dos, and let's also change the widget description. Both of these strings are shown in the widget preview when the user wants to add a widget to their home screen. So for example, here for a description, we could say, view your latest to-dos. Just like this. Okay, so now we have told the system that our widget supports both the system medium and the system large widget family. But now we have to actually implement both of these size classes. And what we will do is we will switch on the size classes that we can reach from the environment and then provide different views to the widget based on which size class is currently selected. For that, there is an environment value that we can read. So just say add environment. And then the key path is widget family. And this way we can basically read the size of the widget. And what we can now do is just switch over this, because it's an enum. You just saw us set it up here in the supported families modifier. Just switch over it and then present different views. So here, let's remove the text and let's say switch widget family. And now we're only interested in 2 cases because we only support system medium and system large. So let's say dot system medium. And let's also say dot system large. And as always, a switch must be exhaustive in Swift, meaning that either we have to cover all of the cases individually, or we need to provide a default case in the end that should happen if none of the other cases holds true. In our case, or in a place like this, the default case will never be executed because we told the system that we only support medium and large. But nevertheless, we need to provide a default case. So let's just say not implemented here, and then we can forget about this. For the system medium and the system large cases, we will now implement widget UIs. So I will just hit Command N, say new Swift UI file, and let's call the first one medium size view. Make sure that it's a member of the widget extension and not of the main app. Hit create. And then let's do the same with a large size view. For both of these, let's move them into a group over here in the widget just so we can separate everything. So let's call this group views. And in here, let's move our widget view, our large size view, and our medium size view. Okay, let's close these and open them up again. Let's start with the medium size view. First of all, we will want to receive a timeline entry, the one that our widget view already got from the timeline, and we will want to forward that into our medium size view. So to work with timeline entries, we need to import WidgetKit, and then over here we just need to say we want to take in an entry, and we can either say provider.entry or we can just directly tell Xcode the type, which is simple entry. let's do the exact same thing for the large size view. So import WidgetKit, and then let's add a var entry of type simple entry. And actually, since we're inside of WidgetKit, we don't even need the previews here, so we can just scrap them from both of these views. That way Xcode won't complain about any issues. And now we can already start to add both of these views into our widget view. So for the system medium, let's just say medium size view with our entry, and then also large size view with our entry. Okay. For the medium size view, we will now start to implement the UI. And for that, I want to show you a pretty neat trick how to have at least a decently looking UI up pretty quick. For that, we will use a group box with a label. So a group box is basically just a wrapper around a bunch of views that groups them up and puts them into a box with some sort of grayish background. And with the label initializer here, we can pass in a label with a title and an image. In our case, we will use a system image. The title will be my to-dos, and the system image will be list.dash. And now inside of the group box, we can put our actual UI. So in our case, we will have an H stack here with first an image of a person. For that, we will use the SF symbol for person. Let's make that resizable. Let's make that scale to fit, and let's also give that a foreground color of secondary, so a nice grayish touch. Then let's add a little divider. So in case you didn't notice, you can place dividers in V stacks, but also in H stacks. And if you place them in H stacks, then they will be just a vertical line. And then in here, let's add a little V stack where we can display the contents of one of our to-do items. Let's give this a leading alignment like this. And then in here we will have two text elements. The first one with the to-do title. Right now we will just have some placeholder content here because we will fill out the timeline provider in the next lesson. Let's have this text as a headline font. So give this the font of .headline. And then below our title, we will have whether it is completed. So here I will just say completed for now, but we will fill this with a tiny bit of logic in the next lesson as well. And then here we'll just say this is a sub-headline like this. At the end, let's also add a spacer so everything is aligned nicely. And then let's also add some padding to the H stack so nothing cuddles with the edges of the widget, I would say. Okay, that's the medium size view already done for this episode. Now let's move on to the large size view. In here, let's also remove the text and let's replace it with a V stack. Basically what we want is we want to have kind of like a notepad feel to this widget. You already saw it in the first lesson how it will look in the end, and let's implement that right now. First of all, there's this little header row at the top. I will give that a spacing of 16. And in here, let's add a little title called my to-dos. Then let's add the current date. So date.now with the format of date time. This is a very handy text initializer here where you can pass in a date and then it will be formatted nicely. And then let's push all of that to the leading edge. To format this a bit nicer, let's give it 8 points of padding. Let's give it a blue background. Let's give it a white foreground color to have a nice contrast to our blue background. Let's clip all of this so it's handled as a single view, because now we will apply a shadow with a radius of 5 points. If we were to not apply the clip modifier like this, then the shadow would be applied to each individual sub-view of our H stack. But we only want the shadow once for the entire H stack, so we need to clip everything into a single view. Okay, next up, we want to display a list of all of the currently open to-dos or all of the currently available to-dos. For that, we will create a for each. And for now, we will just feed this with random numbers. We will not even use them. We will just say underscore in because we don't even care about these numbers. In the for each, let's create an h stack with a circle. This will basically be the indicator if the to-do is already completed or not. And here, actually, we don't need to say ID. We need to say self as the identifier. We don't want the full circle. We only want to stroke its border. So we will say stroke with a line width of 2. Let's scale this a little bit with a frame of 30 by 30. We don't care about the alignment since it's just a single circle. And then let's overlay something here. We want to overlay basically a little check mark if the to-do is already completed. So we will say if true for now, since all of this is just mocked. If true, we will have an image with the system name of checkmark. Okay, so that's the first part of our rows. Next, we want to add the to-do title. Okay, and then let's push everything to the leading edge with a spacer. Let's give this whole thing a bit of horizontal padding. And then also add a divider underneath. Okay, now that we have implemented both the large and medium size view, let me run them on the simulator and show you how they look. Okay, so the simulator is now running and you can already see our medium size widget here. So all of this is a group box. Up here you can see our label that we added at the bottom here. Then there's this scaled system image, the to-do title, and that it is already completed. And if we swipe over to the next side, we see a tiny bit of an issue with our large size view, and that is because we have too many lines or too many cells here. So let's reduce that to 6 and run it again and have a look. Okay, this is already looking a lot better. So we have our header here. The only thing that I forgot to do is to add a little spacer below our for each, so we don't have that white space at the top there. So let's add the spacer here. Let's run this one last time. Okay, and there you can see now the UI looks exactly how we wanted it. We have our header here with the blue background and a tiny bit of shadow at the bottom here, if you can even notice it. Then we have the title of my to-dos and the current date. And then of course we have our rows of our different to-do items. As you know, all of these are mocked right now. Okay, in the second part of this lesson, we will have a look at deep links. So basically we want the user to be able to tap somewhere on the widget and then open up a specific piece of information inside of the app. To achieve that, there are a few steps that we need to take. First of all, we need to set up the target URL in our widgets using either the widget URL modifier on the entire UI or using specific link views, for example, for our rows here inside of the for each. And then we also need to handle the onOpenURL modifier inside of the main app that basically handles what the app displays when it gets opened through a widget URL or any kind of deep link for that matter. First of all, we will have a look at the widget URL modifier because it's a tiny bit easier to use. For that, we just have to add it as the last thing in our medium size view. So the widget URL modifier, which needs a URL, and we will construct that right now from a string. I will tell you about this once we basically parse the URL in the main app, then you will see how all of this works. Basically, what I usually do as the scheme, I will just say the app name, so just my app in this case, ://, then the different routes basically. So here we'll have /to-do, / and then the identifier of a to-do, which we will later on get dynamically from our timeline provider. Right now I will just hard code this to be 1. Okay, and that's already the widget URL modifier. This is all we have to add to our widget to open a specific thing inside of our app, or to at least tell the app so, because right now the app doesn't handle anything. Before we do that, let's have a look at the link view for our large size view. For that, we will grab our entire H stack here, copy it, and embed it in a link with a destination URL, and then as the label, we will just paste back in the h tag. And now you can already imagine this URL is basically the exact same thing as before, but the main difference is in the widget URL modifier, you can pass in an optional URL, which is happening here because the string initializer always gives back an optional URL. But in the link view, you will need to pass in a non-optional URL, so we will have to false unwrap this here. In a real application, you might not want to do that. You might want to construct a URL at a different place, be sure that it exists, and then pass it into your view. For now, in here, we can basically put the exact same URL as we had in our medium-sized view. Once again, this identifier here is hard-coded right now. We will replace this with the identifier of that specific to-do item later on. Alright, that's already everything that we need to set up in our two widget views, so we can close those up now, and we have to move into our main app in our content view now. We will now have to add the onOpenURL modifier at the end of our content view here. And this basically gives us a closure passing in the URL that the app caught when it was opened from a URL. This is basically not called when the app is launched regularly. This is only called in our case if the app is launched through the widget. So if the user tapped on the widget, then this closure here will get called. And now our task is it to parse the URL, make sure that it's in the correct format, download the data that we want to display, and then display that data. So first of all, let's make sure that this URL is correct. So we will have to check if the scheme is correct. And the scheme in our case needs to be my app. So if we one last time go back into one of our views, the scheme is basically this right here. In a web URL, this would be HTTPS, for example. Next up, we will have to check that the host is to-do, url.host equals to to-do. That's basically this route that I mentioned before. And then lastly, we need to extract the identifier. So let's say let ID equals an int from our URL's path component number 1. So let's just say path components at the position 1. And that will be the number here at the very end, which we hard coded right now, but will then be filled in from our actual to-dos. Now that we have all of that, let's make sure that in case any of this is not working, we will just return out of the closure and do nothing. You can also print that there is an issue here in case you want to debug it somehow. Okay, now we have everything that we need. Basically, that's just the ID. Both of these are just error checks. Now, I've already told you about this in the first lesson. We will use the getToDo function of our to-do service. I've told you that this is using the new Swift concurrency features and that it is an asynchronous function that can throw errors, but in the end returns us a single to-do with that identifier that we pass into the function. So let's use that, and since we're not in an asynchronous context, we need to first of all create a task. I already told you this function can fail, so we need to wrap it in a do catch block. And then for now we will just print the error, but in reality you should handle the error in an adequate way. Now let's get to the meat. So we want to download our to-do from our service. So let's say let to-do equals try to await. All of this with concurrency stuff. We already talked about this in the first lesson. If you want to learn more about this, just check this with concurrency lessons. They will be linked down below. So we will try to await the to-do service. We have a shared instance here, the getToDo function with the identifier that we extracted out of the URL here. So let's just pass in that ID. Once that finishes, once the await is done, basically, we need to switch back to the main queue because this can happen in any queue. And now we want to update our UI, so we need to be on the main queue for that. And if you remember from the first lesson, we have this state of the selected to-do here. And if we set that to a to-do, then a sheet will be shown with information about that to-do. So we can just say selected to-do equals our to-do that we just loaded with our getToDo function. Okay, this was a lot of talking, a lot of code. Let's run it in the simulator and see how it works. Okay, so first of all, let's have a quick look at the WidgetKit Course app here. Okay, everything still looks good. Now let's have a look at the medium-sized widget. Remember, we added the widget URL modifier here, so you can tap anywhere inside of the widget. Then the app will open up and it will tell us all of the information about the to-do with the identifier 1, because that's what we always passed in here as a hard-coded identifier. And then if we close that again, go to the home screen, and now over here in the large size widget, you will have to have a very, a sharp eye here. If you click on the individual cells, then they will get highlighted a tiny bit like a button, and the app will get open. So let me click on the third cell here. You saw there was that little subtle button click animation. Now the app opened again, and we once again see information about the to-do number 1, because that's just what we hard-coded. Okay, so in this lesson, you learned about different size classes in widgets and how to show different UI components for those. You also learned about deep links using widget URL, link, and onOpenURL in the main app. Learn how to provide data to a widget by reusing a service class from the main app, and how to schedule that data in a timeline. Hey Code Crew, this is Flo. In this lesson, we will finally fill up the widgets with some life as we use the existing to-do service from the main app. We will also fill out the timeline provider and talk about different ways to schedule content for your widget. So let's get right into it. Before we can start filling out the timeline provider, we need to do a few setup things. As I already mentioned, we will want to reuse the to-do service. In order for us to be able to reuse the to-do service in our widget extension, it needs to actually be a member of the widget target. Right now, let's open up the file inspector on the right-hand side. And then under target membership, you can see that the to-do service is only a member of the main app target. So let's also add it to the widget extension. This is one of the 2 files that we need to add. The second one is to-do itself. As you can see, we will return arrays of to-dos and single to-dos in our to-do service. So we definitely also need to have the to-do struct inside of our widget extension. So let's go over to that file and make sure that it's also a member of the widget extension. Next up, we need to do one more setup step before we can implement the timeline provider, and that is adding the data to our timeline entry. You already learned about the importance of the timeline entry. This is basically what is carried throughout the timeline and provided to your widget by the system at the correct date with the correct information. The date is already specified here, which is a requirement from the timeline entry protocol. Now let's also add the information, and that's the to-dos that should be shown at a specific date in our widget. So let's just add a to-do array here to our simple entry. Now we can actually use this entry to schedule updates in our widget using our timeline provider. So we can close the simple entry here. We can also close the to-do over here. As you can see, now it doesn't compile anymore because we changed the requirements for our simple entry. It now needs a date, but it also needs a to-do. So let's try to fix all of these issues, and at the same time I will explain you how each of these functions work. Briefly, let me explain to you the placeholder function. And actually, let's not make me explain it to you. Let's just have a look at the definition. The definition of the timeline provider. And then you can see there are very, very long descriptions of each of the functions for the placeholder function, the getSnapshot function, and the getTimeline function. The placeholder function provides a timeline entry representing a placeholder version of the widget. This is, for example, used when your widget renders for the first time. It can also be used in a widget gallery, but I think there they actually use the getSnapshot function now. So basically, we don't really need to care about what we return in the placeholder function, as it's just a placeholder while the actual widget is loading. So let's add the to-dos here to our simple entry. And to make life easy for us, let's create an extension on to-do to create some preview or some placeholder to-dos with a given ID. So let's go back into the to-do definition. Let's create an extension of to-do. And in here, let's create a function called placeholder that takes in an ID, which is an integer, and returns a to-do for us. And now we can use this in our get placeholder or in our placeholder function, and also in other places later on, for example, for previews. The function is really easy. Just construct a to-do here using any user ID. It's just a placeholder. It really doesn't matter. What's important is that the ID is unique because the to-do is identifiable. We have a list iterating, or for each iterating over all of the to-dos in our large size widget. So it is important that the IDs are unique, and that's why we're passing in a ID here in the placeholder function. Let's just pass that right into the to-do. For the title, let's just say placeholder, and for completed, let's just say a random boolean, so either 1 or 2, either true or false. Okay, now that we have this placeholder function back in our provider, we can now use that placeholder function here to fill out our list of to-dos. Let's make one with the ID 0 and one with the ID 1, and then that should be good in our placeholder function here. Next up is the getSnapshot function. Here we also have to create a simple entry, or one single entry, but instead of returning it like we're doing in the placeholder function, we need to call the completion handler with this entry. So very similar, but now this can actually be called on your actual widget, so we cannot use placeholder data here anymore. Instead, we will use our to-do service to get all to-dos. For that, let's remove everything that is auto-generated here. And since our to-do service uses the new async await pattern, let's directly start off by constructing a task so we can use asynchronous stuff. And I can already spoiler it to you, we will also need to catch some errors. So we can also directly add a do catch block here. Now inside of the do block, let's fetch the to-dos from our to-do service. So let's say let to-dos equal try to await to-do service dot shared dot get all to-dos. You already know this, we already used this, or I already explained to you how this works. Next up, let's construct a simple entry. So let's say let entry equals a simple entry with the date of now and to-dos of the to-dos that we just fetched here. And then let's call the completion handler with that timeline entry. So let's just say completion with the entry. In the catch case, however, we also want to call the completion block. This time, let's also return some placeholder. So let's just say completion, simple entry with the date of now, and to-dos, we will just use placeholder 0. Now you can see here that the instance member placeholder cannot be used, and that's because we forgot to say that this is a static function. So we can directly call it on the type to-do instead of a specific instantiated to-do. Now these errors should also go away. Okay, awesome. Now the last part, which is also the most interesting and most important, is the getTimeline function. Let me remove everything and then let's go through the function step by step so you understand how it works. Similar to before, we also have a completion handler, but this time the completion handler doesn't accept one entry, it actually accepts a timeline of entries. That timeline is a collection of entries like an array, but it also has a refresh policy. That's the last thing that we will handle when setting up this getTimeline function. First of all, let's do the same setup as before. We know we're going to use the to-do service, so we will need a task. We also need a do catch block. Inside of the do block, let's fetch all to-dos once again. So let's say let all to-dos equal try await our to-do service dot shared dot get all to-dos. This is the exact same stuff as before. Then let's actually do a little trick here. If you remember, in our widget UI, we will show a bunch of different to-dos in our large size view. This UI is meant for small amounts of data, not for large amounts of data. The UI will break if you pass in, let's say, 50 to-dos, because then the top bar will get pushed out of the screen. So we will just use the first 5 to-dos that we get from the service. So let's say let 5 to-dos equal an array. An array of our all to-dos dot prefix of the length 5. This will give us the first 5 entries of the all to-dos array. That is not actually returning an array, it's returning an array slice, but we need an array, so we will construct a new one here. Next, let's also create a timeline entry. So we will just create a new simple entry for the date of now with our 5 to-dos in it. Up until now, this is very similar to the getSnapshot function. And actually, we should probably use this prefix 5 approach in the getSnapshot function as well. So let me copy it over and do it like this. Okay, to make sure that the getSnapshot function also doesn't break the UI. Okay, so now we have our to-dos, we have our simple entry. Now what we need is a timeline. And there are a couple of different ways to do this now. One way is to create a bunch of different entries, for example, for right now, in 1 hour, in 2 hours, in 5 hours, and so on, and pass all of them into a timeline and tell the timeline to refresh once nothing is left in it anymore. So in our case, in 5 hours. Or what we are going to do, construct a timeline with a single entry and tell it to refresh after some specific date has passed. The idea is basically, if you have content that you can already schedule right now throughout the day, for example, if you already have the user's calendar, you can schedule the whole calendar widget for the whole day. But if you rely on live data that you download from a server, which is what we're doing in our to-do service, then it is always a good idea to only schedule 1 or 2, maybe 3 timeline entries and then force the timeline to refresh. That way, you will always have the most up-to-date information. So we will do the later. We will create a timeline, and this will accept an array of entries. So we will just create an array with our single simple entry in it. And then for the policy, you can just hit dot, as this is an enum, very handy. You can see there are 3 different reload policies. The first one is at end, so the timeline would reload when no more entry is left. The second one is never. I think this is very self-explanatory. This means that the app itself will never reload the timeline, but however, it will get reloaded sometimes. For example, if the user restarts their phone, adds or removes the widget, things like that. The system decides when the timeline is really reloaded. You only tell the system your preferences, basically, as the developer. And then the last one is after a specific date, which is what we will use. And the date that we will use is now, advanced by basically 60 seconds times 60 times 30. So basically every 30 minutes, this timeline should get refreshed. In practice, this will probably not happen every 30 minutes since timelines only get refreshed when the user is actually on their home screen. So if the user has their device in standby for a few hours, then the widget will never get refreshed and will only get refreshed once they view the home screen again. Okay, and now the last thing, let's call the completion handler with our timeline again. Okay, and now in the catch block, we will just have our placeholder data once again. For that, let's create some timeline entries. This is just an array of simple entry, just one for now. So let's say the date is now, and the to-dos is dot placeholder with the ID 0, just one for now, doesn't really matter. Hopefully this catch block will never take place. Then let's also create a timeline, which is just a timeline with the entries array, and with the reload policy we will just copy over the one from up here. Basically what this would mean is that after 30 minutes try again to build a timeline. Okay, and then let's pass the timeline to the completion handler as well. And with that, our timeline provider is already done. Now let's use all of these pieces of data that we passed into the simple entries inside of our actual widget views. To do that, let's go to the medium size view. Okay, in our views previously, we hard-coded all of the data, like the to-do title and whether it was completed, but also the to-do ID down here in our deep link URL. In the medium size view, we only want to show one to-do. So to do that, let's grab the VStack, let's cut it out. And in here, let's say if let to-do equal our entry dot to-dos dot first. We will just access the first to-do, and let's paste back in our VStack. Now in here, instead of this hard-coded string, let's say to-do dot title, and instead of the completed, let's say to-do dot completed. Let's use the ternary operator here. So let's say if the to-do is completed, we want to say completed, and else we want to say that it's open. As this is a unwrapping of the first object, it might be nil. So there might not be any to-dos in the simple entry, for example, because we couldn't fetch any from the server, or because we succeeded to fetch from the server, but the server just returned an empty array. In this case, with the JSON placeholder API, this should never happen. But in your main app, you might want to put an else block here as well, and then display some error state. You could, for example, say couldn't load to-dos, try again later, or something like that. Okay, now let's also replace the hard-coded ID here in our widget URL. For that, let's say entry.todos.first.id. This is optional, but we can't have an optional here. So we will have to provide an alternative basically, and we will just nil coalesce it with 0. Okay, that's it for the medium size view. Let's jump into the large size view as well. Okay, in the large size view now, if you remember, we had this hard-coded 0 through 6 range. Let's get rid of that, and instead let's say entry.todos. We don't need to provide an identifier because we did mark our to-do as identifiable itself, and it does have the ID property. Okay, let's go top to bottom here. So the first thing that we need to replace is the ID in our deep link. For that, we can just say todo.id, and we actually need to grab the to-do in our for each for that to work. Then we had our if true here. This of course should mean if to-do.completed, only then we want to show that little check mark on top of the circle. And then our to-do.title also, let's grab that one from the actual to-do. Okay, that should be it. Let me spin up the simulator and let's have a look at if everything works, if we can see all of the to-dos, and if the deep links still correctly link into the app. Okay, so as you can see, it doesn't quite compile yet, and that's because we still have our preview down here, which doesn't have the updated simple entry initializer. So we also have to pass in some to-dos into our little SwiftUI preview here. And let's also just use the placeholder function for 0, and then also another one for 1. And I think this should be it now. Yeah, looks good. Let's compile now and see if it runs. Okay, so the simulator just launched and I added all of the widgets. First of all, here you can see the medium size view. It fetched one of our to-dos, and if we tap on it, then the app will open up and the little sheet will come up with some more detailed information about that to-do. And if we go back to the home screen and move over, then we can see our large size widget, which also fetched the last 5 to-dos as we specified using the prefix operator. And if we tap on any of these to-dos, then the fitting section will also open up and show up in the sheet because we passed down the correct ID in the deep link. This was the final lesson of the 3-part WidgetKit course. In this series, you learned all the basics about WidgetKit. How it works, the way updates are scheduled, multiple size classes, reusing existing code, and deep linking into your app. Use your existing WidgetKit knowledge to create a lock screen widget for iOS 16. Hey Code Crew, this is Flo. In this lesson, you will take your existing knowledge of WidgetKit and bring it to one of the biggest iOS 16 features, lock screen widgets. You will learn about the new size classes that got introduced and how widgets work on the lock screen. And just a quick disclaimer, right now I'm using the Xcode 14 beta version, which you can find the download link of right below this lesson. The actual full version of Xcode 14 will be out later this year. I would guess that it will happen about in September. Until then, you will have to use the Xcode 14 beta because we are using iOS 16 APIs. So of course we need the iOS 16 SDKs as well, which are part of the Xcode 14 beta. I think you got that point, so let's jump right into it. First of all, let's quickly recap how WidgetKit works and what you have already learned in this course. So a widget, just like a SwiftUI app, has an add_main annotated struct. It's not an app, it's a widget. And in here you have a body of widget configurations. In this case, we just have a static configuration with our specific view inside, which is just called a widget view. This configuration always has a name, which is just a string, or also called a kind, and also a timeline provider, which is our provider that we had created. So let's look into that next. The provider is or conforms to the timeline provider protocol, which has to implement 3 different methods. The placeholder method for the widget gallery, the getSnapshot method, and the getTimeline method. We have already implemented all of these in the previous episodes or in the previous lessons of this course. So if you're unsure about how any of this works, just go back a few lessons and rewatch them. The timeline provider basically schedules timeline entries for our widget view. So next, let's have a quick look at our simple entry. So we have a struct called simple entry that conforms to the timeline entry protocol. It always has to have a date associated with it so it can get scheduled by the system. And then in our case, we also pass in some to-dos that we got from our to-do API. So let's look at a to-do. There's also just an identifiable and decodable struct. It has a user ID, an ID to make it identifiable, a title, and a flag whether it's completed yet or not. And now if we go back to our timeline provider, you will see that we use our to-do service.share.getAllToDos function that does something in the background, doesn't really concern us in the widget here. And then we get back to-dos and we only take the first 5 of them. That means that when a widget is shown to the screen, it always has an entry associated with it, and that entry always has 5 to-dos associated with it as well. And then all of that data is displayed via the widget view, which is just a plain old SwiftUI view. It has the timeline entry, so we had it here specified via provider.entry, but the actual type of this is, let me add that as well, aka simple entry. So the provider.entry, that's basically a generic, so the entry is a generic type of the timeline provider, which is then during compilation resolved to be a simple entry. If we have a look at our provider, then you will see we always return simple entry instead of just any timeline entry. So this is basically its associated type. Doesn't really matter right now though. And then in addition to the simple entry, we also grab the widget family, which is basically the size class from the SwiftUI environment, and then display different views depending on which size class this got passed to or is displayed in actually. So right now we only implemented the system medium and the system large size class in our widget view. And if we have a look back into our widget, and you can see we added the supported families modifier and passed in the system medium and system large size class. Let's start adding the lock screen widgets. This is actually super simple. And the only thing that you basically have to do is to add the 3 new supported families. So let's get started by just hitting dot and pressing A, and then you will see that there are 3 new accessory families added. There's accessory inline, which is the section above the time on the user's lock screen. There is accessory circular, and there's accessory rectangular, which are the small and the wider widget sections below the user's time on their lock screen. Now Xcode is yelling at me because, let's expand this error here. The new accessory widget families are only available in application extensions for iOS 16 or newer. And that's because we haven't updated or we haven't set the deployment target to iOS 16. It's still at iOS 15. So let's jump into our Xcode project file, select our target, and for the iOS version, let's scroll up to 16.0. And I think for the widget, we also need to select that. Yeah. So select the widget extension and then scroll up to iOS 16.0. And now that error should go away in a second once Xcode decides to reevaluate it. And there it goes, it's away. Okay, so all you had to do to support the new widgets was adding these 3 new supported families. Now, if we jump back into our widget view, you will remember that we switched over the widget family and we only had 2 cases for the medium and the large size class. In any other case, this default case would be run, which is a text saying not implemented. That's of course not really nice. So let's replace that and add some new widget UI here. So let me clear this up a bit. Let's add the new cases for the new accessory inline, accessory circular, and the last one, accessory rectangular widget families. Now, as I just said, inline is the one that's displayed above the user's current time on the lock screen, and circular and rectangular are displayed below the current time. For the inline one, I would recommend you to only add text. And I think that SwiftUI is actually smart enough to remove anything from that widget that's not text. So we will just add a text of our entry.todos, and we will grab the first one and just display its title. Now, first here is an optional, so we will have to optionally unwrap that or nil coalesce that, that's what the operator is called, and just say no to-dos if there's no first to-do in that list. So that's super simple. And then for accessory circular and accessory rectangular, I will actually use a new view that was also added in SwiftUI on the iPhone, at least with iOS 16. I think it already existed on the Apple Watch for complications, and that's the gauge. So we will just, for the circular, we will just add a gauge with a value and a label. And as a value, we can, for example, say the number of to-dos that were completed divided by the number of to-dos that are not completed yet in those 5 that are in our timeline entry. You could calculate that. An easy way to just try all of this out is to just set any double value, so 0.7 in that case. A gauge always goes from 0 to 1, so that's basically like a progress view. You can imagine it to be like that, but we will have a look at it on the lock screen in just a second anyways. So let's expand this label closure here, and in here we can just put anything that we want, and I will just put a text with our entry.date, and also let's format that a bit. So let's say .date time, and we just care, for example, about the year. And that way we will have a gauge displaying 0.7, and then the label will be the date of this timeline entry, but only the year of that date. And then for accessory rectangular, let's actually use the exact same thing as for accessory circular. Let's copy paste that. And then let's also add some gauge styling here. So there are a few different gauge styles that we can add. And since we're currently in accessory circular, let's just use the accessory circular gauge style, and then also the one for rectangular. So accessory linear in this case. Okay, let's give this a run and have a look at how it works on the user's lock screen. Okay, so the app is now installed on the simulator, so we can just press Command L to lock the simulator, and then press this little house icon here again to go back to the lock screen. Just press and hold on the lock screen and hit Customize at the bottom. And then you will see that there are 3 different sections that can be customized by the user. The top section, which has the accessory inline widgets. The center section, which just has the time. The user cannot really customize this. They can only change the font and the font color, I think. And then the bottom section for accessory circular and accessory rectangular. So let's start at the top. Let's press on the first section, and then we can scroll down until we are at the WidgetKit Course app. And let's select that widget, and then you can see this is probably the title of the first dummy to-do that we had in our, that we got from our API service. And then let's do the same with the bottom section. So let's remove this calendar widget here. And then if we scroll down to the WidgetKit course, we can select it, and the user will be able to see all of the available lock screen widgets, which in this case is the accessory circular, which is this gauge with a value of 0.7, so that's about right. And then as a label, it has the current year, because that's the text that we added here. So let's select that first. And then we also have the accessory rectangular, and now a very interesting thing is happening here. The gauge looks completely different, of course, because we gave it a different gauge style, but it also does not show its label. So you'll have to keep that in mind when you're using the gauge view, not entirely related to just WidgetKit and lock screen widgets, but just in general, keep in mind how the gauge view works. So let's also add that. And you will see the rectangular widget is a lot larger, about twice the width of the circular widget. So let's exit out of all of this. Let's hit done and select this lock screen. And then you will see that we have all 3 of our widgets that we just created here right on the user's lock screen. So in this lesson, you learned about iOS 16's new lock screen widgets.